When we talk about AI hallucination, we usually mean a simple content error. You ask an AI to solve a math problem or summarize a document, and it gets the facts wrong. It is a minor annoyance, similar to a coworker making a typo. The actual threat is silent identity drift. As a system adapts to new prompts and context windows over time, its internal state shifts. It abandons its original, authorized role and morphs into something else entirely, all without alerting the human overseer. To catch this drift, the industry relies entirely on software. Engineers deploy secondary AI agents, text logs, and semantic verification loops to monitor the primary system. Alan Turing proved why this fails in 1936. If your verification tool runs on the exact same Turing-complete substrate as the system it is verifying, both share the exact same failure domain. As the primary AI seeks lower thermodynamic energy states and physically deviates from its original memory layout, the software checking it drifts along with it. The measurement instrument is compromised by the exact environment it is trying to measure. You are no longer managing a defined agent. You are unknowingly babysitting a system that has hijacked your oversight capacity, reading text logs that tell you the machine is stopped while you are already sliding out of control. When large enterprises face severe operational risk, the standard procedure is to outsource the liability. They call an underwriter and buy an insurance policy to cover the gap. This diagram illustrates a correlated measurement loop. Actuaries price risk based on independent variables. If a software verification tool shares a computational substrate with the AI it verifies, their failure modes are mathematically correlated. The resulting risk cannot be quantified. Because the risk is unmeasurable, the enterprise insurance market sits at a coverage gap of exactly $0 for catastrophic structural drift. You cannot pay a premium to make an unquantifiable Turing-complete loop disappear. Companies try to push this liability upstream to the foundation model providers. Those $3 trillion vendors are only selling the raw compute layer and the reasoning engines. They do not hold the liability for what happens inside your specific application. The legal exposure lands entirely on the enterprise deployer, the organization that builds the interface, points the model at proprietary data, and interacts directly with the end customer. The enterprise absorbs 100% of the catastrophic exposure directly onto its balance sheet. There are no financial exit ramps available. This balance sheet exposure turns into an immediate legal crisis on August 2, 2026, when the EU AI Act enforcement window closes. The legislation mandates independent verification for all high-risk AI outputs. Independence is an established regulatory standard with 50 years of case law behind it, tracing through product safety and financial regulations like Sarbanes-Oxley. Under this legal standard, an auditor is explicitly prohibited from sharing failure modes with the entity it audits. If a deployed system cannot pass this conformity assessment, the enterprise faces a direct fine equal to 7% of its total global revenue. Because software compliance tools share the Turing-complete substrate of the AI, they share its failure domain. Every software-based AI safety product currently on the market becomes legally obsolete the moment that enforcement window opens. The only way to satisfy the independence requirement is to drop beneath the software abstraction entirely. Verification must be anchored in the physical silicon. This diagram shows the S equals P equals H unity principle. It mathematically locks the semantic meaning of an AI's intent directly to a specific physical memory address in the hardware. The architecture uses non-Turing-complete combinational logic gates at the memory cache level. Because these gates do not execute code, they cannot drift. They simply monitor the physical boundary crossings of the data. If an AI agent attempts an unauthorized context shift, it physically displaces data from its assigned hierarchical coordinate. This displacement triggers an L1 cache miss, a sub-nanosecond hardware alarm that trips before the software is even aware a violation occurred. Probabilistic software logs offer educated guesses. This mechanism provides 100% structural certainty. It enforces compliance through the unforgeable laws of thermodynamics and geometry. Enterprises now face a strict binary choice. They can carry uninsurable, catastrophic liability into an active enforcement window, or install this physical ground truth to convert their AI into a legally certified asset.